This conference will now be recorded.
All right. Now in Kubernetes, we were seeing different kinds of objects, right? Suppose if you have a replication requirement, so then we have seen there are three types of objects. One is deployment, and we have daemon set, and we have stateful set. Okay, so these are the three objects. Again, just to give an overview, so when you have an application which is stateless application, that is when you are going to use the object called deployment. And internally, the deployment object will be creating a replica set and then pods. However, the deployment object will create the number of replicas that you have mentioned. So the replicas has to be mentioned by us, and followed by that, it creates the pods randomly on whatever the machines in which availability is there, and it creates everything together, right? And it uses a load balancer, or typically it uses a service which will be doing the load balancing. However, if you want a replica to be available on every machine which is there in the cluster, then you're going to use daemon set. But if you have an application of the type stateful, then like database, then what you need is a new object of the type stateful set. And stateful set will be what it will do. It will not create the replicas immediately. It's going to generate it one by one. That is the same way when you're trying to do a shutdown, it will be doing a graceful shutdown by one, and it will be using a headless service. Okay, so that's what we learned so far in the last week. Now, let us talk about another object that we have, which is objects. Okay, now what exactly a job represents? Now, many times, see, if you use the replication object, what it does is it will be ensuring you that if you define a replica, whether it could be one or multiple replica, it will always make sure the same replica is running, right? Now, let's say deployment. In the deployment, if I say a replica is one, it will always ensure that if the pod goes down, another pod will be replaced for that. That is why we call it as replica. So that at any point of time, you will be having the particular pod running in any machine. Okay. Now, there are certain scenarios where you just want to use the pod to run some task only once, and you don't want to kind of recreate itself. That means you don't want the ability to have replication. Okay, forget about scaling. Now, I don't want a pod to replicate, but to do some activity which is needed just for one time activity. So it is like I want to do some work for which if I have the ability where Kubernetes needs to just create a pod, run the task, whatever you want to do, and once the task is completed, you should be just deleting the pod. Okay. So if that's the kind of situation, then we need a new object called jobs. Okay. So what are the examples? So the examples is when you have an application, for every application, you have to frequently delete the older logs. Okay, that is what we call it as log rotation. Now, every organization would be doing it. So now, over a period of time, you have to keep running some tasks which will do the log rotation. Now, typically, log rotation will be something like, let's say, my application is generating many logs. Now, over a period of 2 hours or 3 hours or whatever that you decide, you have to keep deleting the older content from the log files. Okay, that's what we call it as log rotation. Now, similar to that, there might be a database which you have to take a frequent backup. Okay, or let's say that there are some tasks which you have to do for maintenance activity, which needs to be run at a regular interval. So for all these kind of activity, if you look at, you just need some pod to be created and a task to be executed, and it should just get deleted. So that's where I'll not be able to use any of these objects, right? Because what will happen if I create an object with these, then as soon as the pod gets deleted, what will this do? It will try to keep recreating the same pod, and the same command or task, whatever you want to run, will be executed again and again. Correct? So that's where the jobs come into the picture. Okay. So think of all the scenarios where for any maintenance activity, you want to do something one at a time. Okay. So if that is the case, then we are going to use a new object called as job, which is just like one-time activity. You create a pod, run something, and you just finish it. Okay. So in that way, a job will be looking exactly like the spec of a pod, because a job is also a pod. But the difference is, if you give a regular pod, then you have the ability to recreate. But now when you give it as a job, you should not be recreating at any cost. You just want it to do the activity and stop it. Okay. Now, what is the difference in the spec? So the spec difference will be, instead of giving it as a pod, you just have to give it as a job, followed by the API version. So this is another change where you mention it as batch, because it can run multiple things. So that's where, now let's see an example. Okay, now if you look at job just by running it alone, you will actually not see any difference between a pod, because you might think, why do I need to create it as a job? I can just define it as a pod, run, and as soon as it completes, it will be finishing. But the next point that comes along with this is scheduling, because now in the cluster, you can schedule a job which can run at a interval, which means at regular intervals I can run, but I cannot run a pod at regular intervals. Okay, that is the basic difference. So if you have a requirement in which you want to run certain things very frequently, or at a regular interval of time within the cluster, you want to create a pod and run some activities just to do once, then you will be defining it as job. Okay. Okay, so here if you see, now we have the API version and the job, that's it. After that, you are going to have the metadata, and then the template of your pod, and then within the spec of your container, you just tell what exactly is the task that you want to do. Okay, and here I'm saying the restart policy is never, because as soon as it gets stopped, or whatever the command that you have given, this is completed, I don't want the pod to be recreated. Okay, so kubectl apply hyphen. Okay, so if you wait, right, because if you look at the definition, we are just saying it's a infinite loop, right? So that is what, it's not even infinite loop. We are just trying to say wait for 5 seconds. So if you look here, once the job is completed, now it will not try to recreate. However, the pod definition will be available. Okay, so we need to make sure if it is a job that we have to delete it separately. Okay, if not, if you have created it as a job, it will not be deleting the pod. The pod would complete and it will not recreate the pod, but the existing spec of it will be still available. So that's where we need to make sure that we have to delete it. Okay. Now, as I said, you will not be actually seeing any difference on why do you have to go to job, because it is the same thing what pod will be doing. But when you say a job doesn't have a meaning without using a cron or a scheduler along with it. Okay. Now, before we go, I can show you another example where we can actually use job to run certain things parallel. Now, let's take another example. Okay. Now, in this, if you see, I want to run 5 pods in parallel, and as soon as it is completed, I don't want to recreate. Okay, now this is an example where you can compare how job will be useful. So what if I tell you that I want 5 pods? What is it? I want 5 pods. Then so far, whenever you say you have a requirement to make sure that 5 replicas are there, then you will have to specify it as replica, and you have to use any one of the replication, right? Like deployments or replica set. But now think, if you define it as a replica set or as a deployment, and if you give the replica as 5, what will happen? As soon as the pod gets completed, it will be restarted automatically, right? Because any point of time, the Kubernetes will make sure that 5 pods are running. So that's where our requirement is, we just have to run it once. So in that, whether do you want to run one pod at a time or you want to run multiple pod at a time, that is in parallel, jobs will be helpful. Okay, so in this example, what I'm doing is the same, where I just want to create a pod which will do nothing other than sleep for 20 seconds. Okay, so like that, I want to create 5 pods together and I want to run. So assume that I have some maintenance activity where I want to run 5 pods, and this should be running for a maximum of 10 seconds. That means beyond the 10 seconds after completing this, okay, so it should be auto terminated. So that is what this active deadline seconds mean. So now when a pod comes up, it will be running for 20 seconds. And once the 20 seconds is done, all the pods will not be recreated because it's a job. And then it will wait for 10 more seconds. And after that, it will try to delete everything because the timeout that I'm giving is 10 seconds. Once the job has been completed, after the timeline that you have given, the pod will be automatically deleted. Okay, so let's try this. So we don't have anything. So let's say kubectl apply. Okay. So you can see all of them has been created. Okay. And at the same time, all of them are running in parallel. So that is what the parallelism meant. But once the 20 second goes, okay, and as soon as it reaches the 10 second, it will make sure that everything is deleted. Okay, so this is how you can see that you can mention to specify that you have to run any number of pods in parallel, and once that is done, everything will be deleted together. Okay, the same thing you will not be able to achieve if you define it as a pod. Getting it? So that's a basic difference. So remember, whenever you have something to run only once, okay, then you can think of as a job. Okay, so in that we can specify even to run in parallel. Whereas as soon as when you say more replicas, if you define any replication object, then it will try to recreate, which is what we don't want. Then we will be using jobs. Okay, same way. A job will not be again used alone. What you need to use is along with the utility to schedule or to run it very frequently. Okay, so that's when the cron comes into the matter. Okay, because in Linux, if you want to run certain tasks again and again, then you'll be using a cron utility, right? So in Kubernetes also, we have something similar where what you want to do is you want to define a pattern on how frequently a job has to be executed. Okay, and then you try to give it as a definition or as a manifest so that at a given regular interval it will be trying to run it. Okay, then let's look at this example. Okay, so if you define the type of your object as cron job, then it additionally has the ability to schedule. So that's where here the API versions and the kind you have to define. And after that, a new or an additional property that you'll be getting is schedule. Okay, and thereafter you're going to define a job template. Okay, so whatever that you have given earlier, the same template you can also give. Okay, even this can have parallelism and the timeout, everything is defined. But the additional thing what we are doing is we are defining to run at a given time. So by this way, Kubernetes will call this at a regular interval, and it will also run the template of your job, which means just make sure that if it is running, it should not be recreating itself. Okay, so that's how you will be having both the job's ability to create a pod and run it once, and in the same way, when to trigger will be taken care by this particular object. Okay, so you can just go ahead and run. So if you wait for almost every 1 minute, because that's what we have given the utility, so it'll be running it automatically. Okay, so again, it's just one of the maintenance object which people might be using it. Again, it's not mandatory that whatever the objects we have, you have to use everything. But in real time, there will be certain scenarios where you might have to use them. Okay, so when a requirement comes in which you want to run some activity only once, and if you want to run it at a regular interval wherein the pod should not be just recreated, then you're going to use job with the help of cron. Okay, or you can just go ahead with a new object called cron job. So that's how it's going to automatically spin, run, and then it's going to stop. Getting it? There, it started running exactly at 1 minute. Getting it? What do you mean by a job? Again, it doesn't have see, if you define it as just a job, it will not be deleting by itself. So that's where you need to use the timeout option, so that once the pod has completed its tasks, you can just go ahead and delete it by itself. Okay, if not, you need to delete it separately. Getting this? Any questions? Hello?
No questions, sir.
Okay. All right. Now let's look at another scenario. Okay, wherein we have a new concept called init containers. Now, what exactly is the init containers? We need to understand. So go back to our pod. So now I've been telling so far that whenever you say a pod, how many containers should a pod contain? Hello?
One.
So by default, every pod should have at least one container. So that's the best practice, correct? And now that container is called as the main container. Okay, so why do we call it as main? Because that is the one which is going to do all the actual task, correct? Now, within a pod, we can also have more than one container, correct? Now, I showed you some examples in the beginning. Now, you can have as many containers that you want, and all of them will be called as main containers only. Okay, because that is what is going to do some activity. But the question now comes is, why do you want to have more than one container? Okay, so that's where the whole question comes in. And if you have one container which is going to do some tasks, because now if you are creating a pod, you will be creating a pod to run some application of your choice. So being that, why do you need two containers? Okay, so that's when let's talk about certain scenarios where in your pod you might be requiring to have one more container. Okay, however, what it is going to do or why it is needed and when you have to create those containers, that's what we will be seeing. Okay, so this scenario is more about having more than one container. Okay, so usually two containers, that's what I'm saying. But in that, we are going to have one container, which is what is actually Kubernetes is going to monitor, so that if something goes wrong into it, it will try to recreate, or the health checks, whatever you're going to do, all those things will be done to your main container. And the spec, whatever we are been giving, is for the main containers. Now, when you're trying to create a pod, and inside the pod, when you're creating a main container, okay, now assume that main container has a database. Okay, and for a database, you want to actually seed some data into it. Now, what do you mean by seeding a data? Anyone? Have you come across this? Okay, when you say a database, a data kind of data that you will have, right? So let's assume you are trying to start a database through a container. Okay. Now, instead of you installing the database, as soon as you create the container, there will be a database available. But as soon as the database is going to come, as a user, if you are interested to work, now before even you can connect, there are certain basic things that you have to do. Like you need to create what we call it as a database, which is nothing but a table with the respective columns which is available. Correct? And you are going to define a user as whom you can connect. So these are the things which you need to do as a first thing that you are installing a database. Okay, so that's what we call it as seeding. Seeding means you are giving basic information. See, like I'm giving you a mobile in which WhatsApp will be automatically be available, assume in that way, so that you are giving it to a senior person. As soon as they switch on the mobile, they should be having the WhatsApp, which they just have to log in. But now, before even log in, you need to make sure that in that machine, in that mobile, you have your basic WhatsApp available and a particular number has been mapped to it, right? So those kind of things is what we call it as seeding. So in the same way, for a database, you need to create a user and you need to create the basic tables, which is what we call it as creating a database. Okay, so these kind of things has to be done so that for every application, you might create a container for the actual database application, but you need to make sure there are some basic data available in it. Okay, so how do you make sure? Because as a user, I might be creating a container, but as soon as the container comes up, I need to make sure that there are some data available. So that's where before even you are starting the application, you need to make sure that some kind of data should be available inside the database. Okay, so this should be one activity that you want to do, which you cannot do because as soon as your main container starts up, your application would be expecting the data to be available in the database. So how do you make sure that before your main container starts, you will be doing this seed data? Okay, seed means put some data. Same way. Once again, as soon as your main container comes up, your application inside it will also try to come up, correct? But what if I say that you need to put some kind of check where there is some other application which has some dependencies. Okay, so you need to wait until that dependencies are completely available. Only then you should be starting your actual container. Because now understand, what do you mean by starting my main container? Whatever the first command that you have given through CMD or entry point, right? So as soon as you say create a container, Kubernetes will be trying to run the first command available. But the question that I'm saying now is, if there are some tasks or dependencies where only after that dependency is available, you want Kubernetes to even create the main container. Okay. So this is the scenarios where how can you tell to Kubernetes, right? So that's not possible in the way that what we have seen, because as soon as I say kubectl apply, it'll go ahead and create the pod, and in the pod, whatever the main container spec you have given, right? If you have given a CMD, it'll try to take it. If not, whatever is the CMD available in the image, it'll try to run that. Okay. And how about a scenario where I want to take some code from a version controlling system before I create my container. Okay, because as soon as my container starts running, I want some data or I want some kind of files to be available inside my container. And if you have to read that or if you have to clone it from a repository, then what will you do? Right? Because before my container comes up, I want to clone it. Okay, not after the container creation I want to clone. Before my container is created, I want to have some clone available. Okay, so where will you do that? So once again, that's a requirement. Or again, when I was talking about config maps, right? Think of certain scenario where as a user, I will try to put a configuration file somewhere, and dynamically when I'm trying to run my pod, I want to first create a config map, and that I should be applying it when my container is starting or my main container is starting, correct? Because when you say kubectl apply and your main container is trying to start, we would be referring it as a volume mount or as a environment variable. But understand this, before that container comes up, we should have made sure that those configurations are available or config files are available. That is where, if you go back to the examples, first I did something called as a imperative method where we took some file called sample.conf, and then we created a sample conf, which is nothing but a config map, and that we try to give it as a reference in our volume mount, correct? So that way, if you want to do that also automatically. So for all the scenarios, what is that we are looking at? You have a pod, and inside your pod, you are going to have your main container, which is what is going to run everything that you want as an application startup. But there are certain situations or scenarios where even before you create or you start your actual container, which is main container, you need certain things to be done, and that too you have to do it in the same pod, not on some other pod. Okay, so for all those scenarios, now we can have one more container called init container. Okay, so as the name says, init means first, because in Linux we have a process called init process, which is nothing but the first process which will be doing all the activity. In fact, when you switch on your laptop or any machine, the first process which will be running is the init. So that way, here, when you're trying to create a pod, okay, any kind of pod, now along with your main container, you can also define a container called init container. Okay, and as the name says, init container is the first container that will be created. Okay, so now you can see in your pod you can have two container. One is your main container, the other one is init container. And when you say a definition about a init container, so what Kubernetes will do is, in your pod, the init containers is the first container that Kubernetes will be creating. Okay, and inside this, whatever the scenarios that I have told, you can just go ahead and do that. So whether you want to seed some database through it, or download some files, or do some git clone, or generate some configuration file, right? All those things you can do inside this container, which is the first container, which is called as init container. And now first pod will get created, or the pod will be get assigned to a machine, and in that init container will first create, and whatever the commands that you have given, just like your regular container, you will also give it under the spec of init containers, and init container will run it inside it. And once the activity is completed, then Kubernetes will go ahead and delete this in first container, which is init container. And only when the init container completes its activity, Kubernetes will go ahead and create the main container. Okay, so that is how first init container will come up, do whatever the tasks you have given in it, and once this completes, then Kubernetes will go ahead and create the main container. Okay, now this way, whatever that the requirement that I told you in the previous slide, everything can be achieved inside this container. And Kubernetes will not be kind of recreating again once it is completed its tasks. Okay, so remember, now you will give some tasks. As soon as the task completes, Kubernetes will just go and create the main container. Okay, and if you want to share some data between this, then you can go ahead by using a volume like a mtdir. Okay, so that's where now assume that I want to do some clone of some repository. Then first I can do a init container, and inside the init container I can do a clone, and that I can mount it to a volume, so that in the main container I can refer to the same volume, so that when the main container comes up, whatever that you have cloned will be automatically available inside your main container. Okay, so that is how the workflow is for any such scenario where you have some dependencies to check, or some configuration file to be downloaded, or to do a clone. All those things you do it through init container, mount it through a volume, so that once the task given inside the init container is completed, then Kubernetes will go ahead and spin up this main container. Okay, remember, so that's where init containers or special containers which will be created in the first place, and once the activity is done, it will go ahead and create the main container. Okay, but if whatever the tasks you have given in the main container doesn't run properly, okay, for certain reason the init container itself is failing due to some error or some command, then Kubernetes will not proceed to the main container, because only after the successful completion of the tasks or whatever you have given inside the init container, it will go to the main container. Suppose if init container is failing for any reason, then the pod will try to restart. Okay, because your init step itself is failing, right? Just like you're booting up your laptop, in the first boot up process itself it's fail, then you will try to reboot up again. The same way, if the init container is failing for any reason, Kubernetes will restart the pod itself. Okay, so remember, first init container will come, finish its activity, and after successful completion, Kubernetes will be creating the main container. Okay, and the other difference is, once the init container is done, that's it, we don't need it again. It's only for the first time when the pod is created. So every time when the pod is created, it's going to execute the init container, and after its completion of successful whatever the tasks you have given, it will go and create the main container. Okay, getting the difference? So how do you define? So that's when, if you just look here, so far, whatever the object that you have defined, so just to take example of pod now. Now, so far, what did that we do? Under the spec, we were defining containers, correct? So remember, anything that you define under this keyword called container are actually main containers. Okay, so that is where we are having only one main container. So now, if you want to define a init container, then just add a new keyword called as init containers. Okay, and under that, same way like how we defined our spec of a container, you're going to define. Okay, now to show you this example, so here, if you look at this example, now this is a pod definition, and in the pod I have a container. Okay, and now let's not worry about this, because before this init containers will be executed. So let's look at this init container. So what is that spec I have given? So I'm telling create a container based on CentOS, and in that I'm doing some task. What is that? So I'm trying to say that I need to run a command. Now what is that command going to do? I'm just saying that stay home, stay safe, and I'm redirecting to a file called temp exchange and a file called test file. Okay, so all I'm doing is creating this file and sleep for 30 seconds. That means the pod will wait for 30 seconds and it is complete. And in that, I have a mount, and the name of the mount is exchange, and the folder to which I have to mount is temp exchange. That means whatever that you're putting here is actually going into a volume. Okay. And what is the type of volume? So now the type of volume, if you come down, I'm giving it as a mtdir. So the meaning of this is now whenever init container comes up, it will be mounting a mtdir into temp exchange, and whatever that you try to store will be available here. And at the end of 30 seconds, this container will be completing its tasks, right? And then Kubernetes will go and create this main container. And in the main container, you can see I'm having the same volume, but mounted into a different folder called temp data. Okay. And that is what I'm again trying to do as a shell script, where this is the standard shell script. I am just trying to run every 5 seconds, in which I'm trying to read this file, because whatever the file that you have put will be available in your volume, and the same volume will be mounted here. So I'm going to read this file. So that's where I'm just trying to show you how a data that I put into my init container will be shareable to main container using the volume. Okay, so that now when I run this, it will be reading this and it will be just printing you a loop of stay home, stay safe. Okay, so watch this. And the reason why I have given 30 seconds here is you can see that when you try to create a pod, first init container will run, and then it is going to typically get into this. Okay, so now the name of the pod, I'll call it as init container. Okay. Okay, so now kubectl apply -f and init. Okay, now quickly watch this. Do you see now when it is trying to create your container, in the status, it's not just directly saying running, but instead it is saying init. Okay, and in the init, how many steps? Because you can have more than one init containers also. So it's not just one you can have, but if you have, then it's going to run everything one after the other. Okay, so that way you can see only when the first 30 seconds is completed for your init container, then it's actually showing it as running container. Getting it? Let me show you again. So now if I just say kubectl logs -f and your pod, so you can see that it reads the file. Okay, so that's how you created an init container, try to redirect a file to mount, and the same mount you're trying to read it from your main container. Okay, so watch it, I'll show you again. kubectl delete. So now when I apply, first main container will come, and in the main container it will be sleeping for 30 seconds, and only after this is completed it will be actually going ahead with the main container. Okay, so that's where, let it complete. Okay, so let's quickly just apply this once again. Okay, so you can see now, first it is creating the init container, and in that there is only one container that you have given, and that's currently running. And once when it becomes 101, in the immediate next second, it will stop and go ahead with your actual main container. You can see almost that 30 seconds is over. Then this is the main container's pod initialization. After that, it goes ahead. Getting it? So what's init container? So remember, init containers are the first one which a Kubernetes will be running inside a pod. And after the completion of it, it will go ahead and start the main container. So this way, anything that you need for your main container, you can make sure that it is available by using the init container. Okay. Clear?
Yes, Adam. So basically the init container job is to do the seeding for main container, right?
No, I didn't get come again.
So init container, like you're saying, is the first container in the pod. So that container is just basically to initialize different components for main container, right?
Yes,
It's just a temporary container.
correct. And it is the first one that Kubernetes will be starting.
Can we say it like a dry run thing? Like a
No, it's
dry
not
run
dry
container?
run. Meaning is different. See, that is actually going to do some activity. Here, I'm just trying to show you a simple example of creating a file. But like I said in the examples of the initial slide, you can actually do a lot of activity, right? So that's where it's not just meant as dry run. It's a container which runs first, prepares whatever is the environment needed for you, which could be like seeding a data, or it could be like waiting for some dependencies to be available, or you can go ahead and do a git clone and make sure all the necessary files are available before your actual container comes up, or generate some kind of configuration file. So make sure everything is available and then go and put inside. Okay, because let's say another point. When my application starts, for certain reason, I want to give the IP address of my pod. Okay, and that when my application starts, I need to give. So how will you give? Because only when your pod or your container starts, you can try to do some activity. But I'm saying you need to get that even before you run the container. Then you can have a init container, prepare whatever the environment that you need, and then you're going to pass it to your main container. Okay.
Right. So the tasks that
Yeah.
we need to verify are all these tasks we have to define in the config file,
Yes.
right? Let's say
That's
we
the
are
same way
okay.
here. So it's the same manifest file where you're going to define all this. So I've just taken a simple pod to explain, but it depends on what kind of object you're creating. For that, how is your init container and main container will look, you have to define.
Sure, thank you.
Others? Clear on what do you mean by init container?
Yes, sir.
Yeah.
Okay. So Now, if you look at a pod or a container, we also have a specific life cycle. Now, this is mainly for you to do a debugging, okay? Because many times when you say kubectl, get pods, you will be seeing different phases of it and different words, right? So that's where let's quickly go through and understand what are the different phases that we have in a pod's life cycle, okay? Now, typically, these are the ones that you should be seeing it somewhere: pending, running, succeeded, failed, or completed, or unknown. Okay, so there's a sequence of how it goes through. So what happens as soon as you say kubectl apply? Okay, then what will Kubernetes do? Kubernetes will be applying the configurations whatever you have given, and it will store into the etcd. Okay, then what happens? As soon as it does that, the pod would have got assigned to a machine. But as soon as it assigns to a machine, the next thing it will do is it will try to download the images whatever it is needed. Correct? So at that point, you will see the state of the pod as pending. Okay, so that is one scenario. If not, assume that Kubernetes is not able to find a resource matching your manifest to assign a pod. Even in that case, the state of the pod is called as pending. Okay, so whenever you say pending, then immediately you have to go and describe and find out what's the problem. Either Kubernetes is not able to assign a pod to a machine, or it is trying to download an image after assigning the pod. Okay, so those two scenarios is where you will be getting the state of your pod as pending. After that, when the image has been downloaded, then Kubernetes will be trying to create the container. Okay, and when it has successfully created the container, then the state of the pod will be running. Okay, so if you have more than one container, again, when I say more than one container, more than one main container, then the state will be running. Okay, remember in the just the previous example we saw, until the init container is not completed and the main container is not started, we never got the running status, right? It was just trying to show as init, and then it was showing it as initialization, which is the pending, and after that it went into running mode. Okay, so running means you have your container created and it is running. Now, for certain reasons, if you go ahead and you say that the container has to be terminated, okay, so that you have done with all the work and you don't want the pod to be recreated. That means you have actually completed all the tasks and you're just going to delete the pod. So before that, if you see the status or the condition, what we have, the life cycle of the pod will be mentioned as succeeded. That means it made sure that all the containers has been successfully stopped. Okay. Then for any reason, if the pod has a container and it's failing, okay, so in that case, the state of the pod will be defined as failed. That means any one of the container, it actually exited with a non-zero value or a non-zero status, then the pod will be considered as failed. Okay. However, for certain reasons, when a pod is running in a machine and Kubernetes is not able to, or the master is not able to reach that node, or the kubelet is not able to pass the information to the master controller, then sometimes you might see that the pod's status will be mentioned as unknown. Okay, so unknown means master doesn't know details about this pod. Okay, that means there is a network issue. And in case if you are trying to delete a pod and it is going to complete successfully, then it comes to completed state. But these kind of things will be like super fast, you will not be able to see. But for certain cases, just know this is your life cycle of the pod. Okay, nothing much, but now we need to understand the conditions of a pod. Okay, so what I just told you earlier is how the state goes, but what exactly is the condition? This is what you will be actually seeing when you describe your pod. Okay, so you can see that these are the outputs that you will be seeing when you say kubectl describe pod, because for some reason if the application is not coming up and you want to do some debug, then you can say kubectl describe, and here you will see pod scheduled, ready, okay, initialized, unschedulable, containers ready. And as the name says, what is pod scheduled? So if a pod has been assigned to a machine, then we call it as pod scheduled. And in that, all your pod is completely ready so that it can go ahead and create the containers. Then it's called as ready. And in case if you have any containers, that is init containers, then it would have mentioned it as initialized, so that, okay, I have started my init containers and I have completed. Okay, but if it says unschedulable, that means there are some constraints where the Kubernetes master is not able to find a machine matching your resources in the manifest. And containers ready means all your main containers has been ready to run. Okay, that means they have successfully created the main container. That is what we call it as containers ready. Okay, so this is how, if you go back and try to do, pod describe, you will be getting all those things. Now let's try this. You can see here. So it says initialized, ready, containers ready, pod scheduled. Now pod scheduled is true, that's it. But again, after some time, if you see, it's still scheduling. The initialized is not yet completed. That's because only when your init containers is completed, then this will become true. Okay. After 5. Okay, now this is a problem. Okay, now it just goes off in second. But now you can see that once your init container has completed, this will be true. And after that, when the main container is about to start, it will say ready. And once your main container has successfully started, it will call it as containers ready. Okay. Getting that?
Yes, sir.
Clear so far?
Yeah.
Okay. Okay, just like your pod, right? Your container also has states. So that is waiting, running, or terminated. Okay. So this is going to be very straightforward. So waiting means when, if you have image being downloaded, so that's the first state of your container. And once your image is downloaded, then the containers will be started. And when it's started, you will be seeing this as running. Okay, and post that, if the container is going to get deleted, then it's called as terminated. Okay, so this is like something straightforward that you have. Now, in this, okay, now when you're talking about state, what happens is you have this life cycle. So when you actually try to create your pod, okay, so the first thing that happens is it creates a init container. Okay, now once the init container is completed, this is where we have another utility inside your container, which is called as start hook or a hook. Okay, now what is hook? Hook is like a trigger. Now here you can actually do some activity before your container deletes or as soon as your container comes up what you want to do. So that's where hooks are nothing but triggers. Okay, so that way before your actual container starts running everything, you can actually have a hook set up in such a way that once your container comes up, the next thing that we can do is go ahead and execute some hook. Okay, so that way it's up to us on the application side. If you have such a requirement, we can do. So that's where whenever your main container comes up, what you can do is as soon as the main container is created, you can go ahead and run some hook. Okay, so this is something which we can do. So I'll talk about what is the hook or what commands you can run in the next example. But just now imagine init container is even before this main container. But here what I'm saying, when you try to create your main container, in that you can actually try to run certain commands, which could be the first one. Okay, and after that it is going to start running your main containers application. Now along with this, you will be having your initial delay. Why? Because only after your initial delay you can start running your checks. Okay, so you will be having your checks that you will be defining. And then when you say, okay, I have to delete a container or stop a container, that is your main container, then before stopping your main container, once again, you can actually do something called as a pre-stop hook. So pre-stop hook means, now assume before my container is going to get stopped, I want to send some notification. Okay, then how do you do it? So that's where these kind of things you can define it as hook. So you can have a hook that could be post start or pre-stop. Okay, so as soon as your container started, you can have a hook which will get triggered. The same way you can have a hook which is getting triggered before it is going to delete, so that only when the hook completes, then the main container will go ahead and stopped. So this way you can have the hooks and the lifecycle defined. Okay, so your init container and then main container. In that, if you have a start hook, which is a post start, it will get triggered, and based on your initial delay, it will be waiting for your health check, and post the health check, it will be marked as success. And then when your container is going to get stopped, before stopping, the first thing it will trigger is pre-stop. So that it's up to us to define this. Okay, now here if you try to compare with the pod's status that we have defined, so when the pod is trying to create a particular init container in a place, and when it is running, you can see it will be in the status called pod scheduled true. Okay, so that's what we have seen. And only when it is creating the main container, and if you have a liveness check that you have defined, and if it is successfully completed, only then it will be calling it as initialized true. Until this place, it will be just mentioning it as pod scheduled. Only when your first health check completes, it will be considered as initialized is true. And when it is going to be considered as ready, only when the first liveness check even completes. After this, it will be mentioning it as ready. Okay. So remember this much. Getting it? So this is how you will be tracking the status. So now you might not be just seeing everything immediately, but keep running the pods at any point of time. If you see the status or describe the pod and see the output, you need to start correlating how it is. Okay. So this is where I wanted to talk about this post hook and pre-start hook. Okay. So what exactly are this? So as we see, you can have some hook, which is nothing but a trigger, which can happen as soon as your container starts coming up, or before your container stops, you can actually trigger some hook. So again, it's depending on what kind of scenarios your application is running, so that as soon as your application comes up, you need something automatically be triggered, or before your container is going to stop, you can run some trigger. Okay, so in that case, what you're going to do is now in your spec of the container, you're going to actually add a new keyword called lifecycle. Okay, so all these things are additional. It's not mandatory that you should be giving, but just again, somewhere like interview, if someone asks, it's good to know. So now understand, so far we never used it, but if we need, then you have to add a lifecycle keyword. And under the lifecycle keyword, now, do you want a post start or a pre-stop? So accordingly, you are going to run some commands. Okay, so here is just an example where I'm trying to create a container based off Nginx. And in that, as soon as my container comes up, I'm just trying to run some command. Again, it doesn't have any meaning over to this, but just to show you, I'm going to define it. And then once this is done, it will be just proceeding further. But when you say stop this container, what it will try to do, it will first try to bring down the Nginx in a graceful shutdown, and then it will be proceeding for the container stop or the pod deletion. Okay, so just remember this, it might be useful. Okay, so there's nothing much other than that, but just as a life cycle, if someone asks you what is a hook, so remember, when your container comes up, as soon as the container is coming up, you can run a trigger which is called as post start, or before your container is going to stop, if you want to run some activity wherein you have to trigger certain commands and do some notification, or one of the common use case what you're going to have pre-stop is, you need to make sure all your instances references is being gracefully shut down. Then you can go ahead and use pre-stop. Okay, now for this, you need to add a new keyword called as lifecycle for every container, that is the main container. Getting it?
Yeah.
Okay. Now, see, all these things are more just for knowledge purpose, because only when you start using application you will see. If not, somewhere if you're looking at some examples, right, you should try to understand that, okay, now if you have to do a deployment of your application, whether it is in a development environment or QA environment or your pre-production environment or production, now it's not just about creating a pod. So you have to now visualize completely. Okay, so how will you visualize? So first you need to have, what will you have? So let's say this. So now if I ask you to define a deployment strategy, now the first thing that you have to do is, okay, I have a cluster. Assume that I have a cluster for my QA. Now in your cluster, first you're going to define, what is this? You need to define a namespace, correct? Now under your namespace, everything will be available. Okay, then under the namespace, you're going to once again define what we call it as quota, which is the resource quota. After that, you have to define, what will you define? You will be defining the limit range so that you make sure what is the default you have to set and within what value you will have. So this is something you will do. After that, now you have to define your actual object. So that's where you need to know whether it's a stateless application or a stateful application, right? So based on that, you're going to define an object. Okay, so let's assume that I'm going to define a stateless object or an application where I can say it's going to be more of a deployment type. Okay, so then you're going to say the deployment object, and for the deployment object, how many replicas that you will be defining. Then over here, you also have to tell, suppose like now we have seen, does it need a init container, or what is your main container definition, right? And post that, you're also going to give if there is a health check that we have to do. And then what? You're also going to give, suppose if there is a volumes, which could be a persistent volume or any other type, you're going to define, correct? And now suppose if you have volume, then let's just assume that you're going to define some volumes, which is going to be shared. And along with it, you might also define that you need some config map or secrets to be defined, right? Again, everything is needed. You cannot just say that I need it. But now, if you take a proper application, you might need all those things put together. So that's where, again, you might be needing some config map or a secret from which it has to take. And on top of all those things, you're going to define your secret, correct? So which is going to be some type. So that's where the whole of your objects or the pod is going to run under your service, right? So whatever that we have learned, everything is going to be put together. This is how your manifest will be looking at. Okay, so it's not just that when I say manifest, you will be having everything separate. You will have everything put together. Okay, so that's where we need to now first understand what is our application and what are our characteristics that we need from that particular application or a pod. So based on that, you're going to define all these things together, which is why we call it as a manifest. Okay, so manifest is like a bill of material. So now for your actual application to come up, what are the bill of materials that you have? All these things put together is what we actually call it as a manifest. Okay, so going forward, if anyone refers to you as your deployment manifest, then they are talking about this YAML file, which has all the definition. Okay, getting it? So it's up to us to define how our object should look like and what are the properties that we have. And based on that, you're going to add or define all these properties put together. Okay, and again, we still have many more, right? Like we have HPA, we can also define that, but it's all about adding more and more properties to your object. So that's how your manifest will be defined. Getting it?
Yes, Adam.
Yes, Adam.
Okay, now before we go to the next topic, let's take a 5 minutes break. You come back so that I'll talk about the remaining things.
This conference will now be recorded.
All right, so see what we have seen until now is what are the different types of objects that we have, how we can use it to define our manifest, correct? Now, the last part which comes here is how am I going to apply it? Okay, because if you understand, it is not that like how we are practicing in a real time, you will be just saying kubectl apply whenever you want. So there is a process where you have to get attached to your CI/CD pipeline, correct? So that now there would be a requirement where if you go back to our CI/CD pipeline, as soon as you do a build when a check-in is available and you need to generate an image and that image has to be tested. So that way, whenever that we are going to do a build, we are going to deploy. So that way now, what is deployment to us? It's all about creating this container, or based on how you have defined your manifest file, you are just going to apply this inside your Kubernetes master, which is what we call it as deployment, correct? So think in this way. This is what we call it as modern deployment. So rather than going ahead and doing all the steps manually, now deployment to us is all about making sure that you have your image generated, which is your Docker image, in which you have all the application required things, and go to the environment in which you want to deploy. In the sense, the environment could be like a QA environment or production or pre-production. Now in that, you want your application to be up and running, and for that, rather than you copying it, configuring it and starting the application, you just make sure that your container is available using the image what you have created. So for that, we are going to use Kubernetes, correct? So just by saying a kubectl apply with the help of the manifest file definition and starting the container and internally running our application is what we call it as deployments. But when I say this, the method that you're going to do the deployment will not be the same for all the environments. Okay, why is that? Now let's say you are trying to do your smoke test. Okay, now when do you do smoke test? Whenever your CI/CD pipeline is triggered and when you are trying to create a new build and that is success, immediately you are going to do a smoke test. So for that, if I say assume that you want to deploy, now for you, I just showed you a simple deployment by using Docker Compose. But that way, understand that is also a deployment which we are doing, wherein we are just creating a container. Go back, we saw that how we created a container and a Redis container, correct? That is your container for your application that we built, and supporting it, there might be another container. That is also called as deployment. But where did we deploy? In our, but there, if you have noted, what did the policy or the method that we did? We created the container. Whenever my build is successful and the image is generated, we will create a container from it. And once the test is done, we'll go ahead and shut it down. If you have not noted, go back and see the startup script that I have given, correct? And there was a test script that I have used, right? So that test script, after testing, explicitly I had mentioned a place where I have given Docker Compose down. That means whatever the containers are running, I just delete it. So only when I have to test, I bring up the container, and then once everything is done, I will stop the container. Okay, so that is what I was doing it in my dev environment. But ideally, now if you go to production or anything equivalent to production like your stage or your pre-production, that is not something you will be doing, right? Because you need an application or your container to be always running. Then when I now have a new build that I have to update, then what will you do? So that means your application is running in production or something similar and customers are accessing, and now you want to replace that containers which is having an image with a container created from a new image. So how do you update? So that's where, are you going to stop your containers and bring up the containers with new image, or what are the different methods that you're going to do. So that's where, even if you're going to do a deployment, there are some strategies that we have to follow. Okay, so that's what we will be now understanding on in Kubernetes. If you want to do a deployment, which is nothing but doing a kubectl apply and bringing up your application and allowing the customers to access, what are the different strategies that we have to follow? Okay, because which is again something important, because when you go to an interview, you cannot just blindly say that I have deployed. Now, if the question comes what kind of strategy that you have followed, then that's also important to understand. Okay, now there are different types of strategies, so we'll try to go through a couple of them which are important. Okay, so that's where at any point of time going forward, if someone says deployment, the next thing that should come to your mind is you're going to make sure your application is going to be up and running. Correct? So this is what we call it as a software deployment. And for that, what is that we are doing? So we are using a tool called container, and using that we are trying to do a modern deployment where whatever that environment we need, we are going to put it as an image, and that image, wherever I create a container, it's going to be deployment. So that I can do it in my dev or in my QA or my performance environment or staging environment or production. So this is how it is going to be different environments. So that way, now what are the different methods that we are going to use to do this deployment, or the strategies that we are going to follow is what we call it as types of deployment. Okay, so typically there are 4 types: recreate, ramped, blue green, or canary. Ramped is again called as rolling update. Okay, so we'll try to understand these. Now for now, at least let's take one and try to understand. Now take this scenario where now you have a deployment object defined and you have 2 pods running, which is called as replica. Okay, so assume that this is what you have already deployed and it is running. Now for creating this pod, you might have defined an image from which you have to take it. Correct? So that's where now if I do a new build and I will get a new image. So what I want to do, if I want to replace these 2 containers, which is having my old image with a new image and 2 pods, okay, that is what we call it as deployment. So the first method of deployment, which is called as recreate, how this method works is, assume that this is what you have. So you have a object called deployment, and under that 2 pods which is running. Now when you say recreate, what we are going to do is, typically we are just going to delete your object which is deployment. Then obviously what will happen, your pods will also get deleted, and then you try to update your manifest. Instead of using the old image, now you refer to new image. Okay, so that's where in the recreate method, you're going to first stop all the pods, and then you are going to define the new image and update, and the new pods or the replicas will be coming up. So such a method where you stop and delete all the pods first and then update and recreate all the pods is what we call it as recreation method. Okay, now typically this is what we have done in our smokes environment, or in the first deployment and testing in our CI/CD pipeline, which is your smokes environment, right? So that's what we have done. So what is the benefit here? So at any point of time, your entire application state is brought up newly. Okay, so you're just going to stop your previous one, and then you're just going to bring up new pods for it. Okay, but what is the disadvantage? So the disadvantage here is, if I go ahead and stop my running pods, then what will happen? I'll not be able to access the application, correct? So that's when this is more suitable for your development environment, because I don't care about my application going down, because whenever I want, I will try to create a pod access it, and once it is done, I'm going to stop. So that the next time if I want, I will first stop the previous one and then try to create new pod. Okay, so this method is what we call it as recreate. Now, instead of using the, what is that? The Docker compose that we had done, if I had used the Kubernetes object, it is also going to be a same deployment. Okay, but now this is what we were actually doing even when we are practicing. So if I had to do some change, I had to typically stop, delete the pods, and then go ahead with updating the YAML or a manifest. Then I will do a apply, right? So this is what we call it as recreate, which is nothing but stopping the previous copies or replicas and then update your manifest and create new pods. Okay, so let's try to understand this. Okay, so logically, now in this example, if you see, I have defined a deployment object. Okay, and in this deployment object, I'm using Nginx as an example. Okay, so if you look at this, I'm defining an image which is going to have Nginx. Okay, and here, if you look, I'm having Nginx 1.10. Okay, so assume this is my first build, and this is the image what I have generated, where the image tag is 1.10, and accordingly you can see that I am using certain labels where version is 1.10, and that is what I have referred everywhere. Okay, and I'm basically requiring 2 replicas. So now if I try to create an object, it will be giving me 2 replicas. Okay, and now this is a web application and I'll be exposing the port 80, and that I will be accessing it through my service, where here I have not mentioned any type of the service, so it's going to be cluster IP. So anyway, for us, we are not actually doing any access, but just to show you. So here, let's just try running it. Okay, now let's go here. So what I'll do, I'll call this as build1.yaml, assuming that this is the first time that I'm trying to do a deployment of this product. Okay, and this is your tag for that application. Okay, now here, if you say kubectl apply, it would come up. And the next thing, you need to make sure that you have a service defined, and this service is going to refer to the label called version 1.10. So whatever this is coming up, you'll be able to see. Okay, so I'll just create build1 svc.yaml. So let's say kubectl apply. Okay, so I've also applied. So you should see now you have your service available. Okay, looks like our test job is not deleted. Anyway, ignore it. But now if you focus here, we have the service available, and internally we have our pods which has been defined from Nginx is also available. Okay, so these 2 things we have. Now let us try to see how our actual deployment works. Now before that, you can actually see the version of Nginx running. Okay, now kubectl get svc. So this is what we have, right? And kubectl describe svc. So I can use this endpoints. Okay, now here, if you go ahead and say the IP that you have obtained and version, you will be able to get the particular version of Nginx which is running. So we have used 1.10, right? So if I say curl -s http, okay, /version, you can see this is the startup page. And what is the version? It is 1.10.3. So that means I have first deployed Nginx version called 1.10.3. Similar to this, in your application in real time, you will be giving a tag which will be corresponding to some build version or your application version. Okay, now, so we have something which is running as a application. So how do you do your recreate? So what do you mean by recreate? Just stop the existing one and then go ahead and create new one. That is what we are going to do, right? So for this, now we are going to have a definition here. Okay. So now if you look carefully, I'm trying to define a new YAML, okay, which is actually a copy of the previous one. Now all the definitions are same. However, the first thing that you have to note a few things over here is the image version has been modified. So earlier I was having 1.10. Now I am updating it as 1.11 because it's a new build. But it is the same label I am using. Okay. And now comes a new part, which is strategy. So now here you have to define what is the strategy that you're going to follow. So here we are trying to tell it is a recreate. Okay, so recreate means what it will do, whatever is there, it will just bring it down and it is going to replace it with new one. Okay, so this is what we are going to do. And again, remember, I'm not going to change the service reference because what is the service doing? If you go back to this example, so my service is still referring to a label called 1.10, correct? So that's where, if you look here, kubectl get pods, forget about this init. Okay, probably let me delete this. Okay, so if I say show labels, so you can see that it has a label called name equal to Nginx and version equal to 1.10. Okay, but now in this, when we say service, so our service is looking at these two labels, and in this label, whatever the pod is available, so it is trying to get us the access. So that is where when you go back and refer to the IP of your VIP service, it was actually referring to our current pod which is running this. That is where you are having 1.10. Okay, but now what I'm going to do is, all I'm going to do is over here, try to update the same object, which is your Nginx. So the name of the deployment object. So what is the name of the deployment object? Nginx. So this is the name of your object, right? Now I could have given a common name, but I just gave it as 1.10. So let's not worry about the name here. But the same object, the difference is now I'm trying to tell update it with 1.11. That is what I'm saying. And second, when you're going to update, follow the recreate method, which means when I say apply this, there is already an object available which is having two replicas based on 1.10. So it has to replace that with new two replicas based on Nginx 1.11. But for that, it is going to just first bring down both the pods that you have with 1.10 and delete it, and then recreate it with new 2 replicas with the reference of 1.11. Okay, so that's what it is going to do. And again, I'm not changing anything to my service. So if I go back and access my service after this, instead of showing 1.10, it's going to show me 1.11 because it's the same label name that we are taking. Okay, so that's what we are going to do. Okay, so I'm going to apply this and see the difference. So we'll say build2.yaml. Now I could have updated the same file, but just to show you difference, I'm keeping it. Okay, now over here, kubectl apply -f build2. Okay, now before that, let's open another command prompt and we'll see the difference how it takes. Okay, so let's connect to the machine. Okay, let's say watch kubectl get all. Okay. So watch this now. So you can see that we have the deployment object, which is running 2 replicas. And for that, it is running based on the old image of 1.10. Okay, but as soon as I run, so you can see recreate method means it will stop both of them and then it will recreate new based on image 1.11. Okay, so that is what we call it as recreate. Just watch it. You can see both of them got terminated, and then it will be replaced with a new replicas where we are going to have, see, it's trying to create new ones, and for that you're going to refer to image 1.11 what we have given. Okay, so it has come up. Now in this, did you see that it just stopped and brought it back? And now the same service, if we try to access, okay, so earlier it was saying 1.10, now you can see it will refer to 1.11. Okay, so this is what we call it as recreate. So on typically development environments, you might be running already existing replicas or pod. So when you say recreate, it's going to simply stop everything and then bring it back. Okay, so I'll show you once again. So once again here, I'll change this back to 1.10. Okay, just to show you. So here it's still running, correct? So watch this. Now once again, if I change, so it's going to bring down and then recreate. Okay, so that's what the concept of recreate. It'll just bring it down everything together and then it's going to bring up your new container. And once it is done, now as a customer or as a end user, you will be still using your same URL or VIP that you have. So you don't have to worry about changing your VIP. Okay, but internally, when I'm doing a deployment, the method or the strategy that we have used is recreate. Now this is what we will be typically doing in a lower environment like a development environment. Clear?
Yeah.
Clear on what is recreate?
Yes, Adam.
Okay. Anyways, I'll stop it here so that there are still many things that we have to see.